Let's look at this problem again. So the goal is to find the most expensive house among those with either 2 or 3 bedrooms, and also the least expensive house among all houses with either 4 or 5 bedrooms. So it should be pretty clear what this question asks to do. It's fairly straightforward. So the main thing, one of the main things I'm trying to teach through this example is how to compute max and how to compute mean. So here is a sort of a fairly simple algorithm to find max. Well, this is a really simple example, but I think it illustrates some basic ideas of programs. So because you have some variable storing state, and then this variable value will be keep updated, and when you're done, the variable will store your result. So there is this sort of a procedural keep updating aspect to it, which is at the core of programming. So we declare a variable to store the current max, and then we will look at each thing in turn, and we compare that with the current max. If it's bigger, then we know we find something that's bigger. So we will update the variable that store current max to be the current value. And when we're done looking at everything, then this variable will be storing the max value. So this is the part of code that will find the most expensive house with either 2 or 3 bedrooms. So there are a few things that I want to sort of explain here. So first, here I put 2 statements on one line. So one declaration and one reading the data. So this is okay. As I said earlier, white space and new line, these are for humans to this makes no difference for a computer. So long as there is a white space, then whether there's one or more, whether there's lots of new line in between, it doesn't really matter. On the next line, I want to illustrate the fact that you can initialize variables with the values. So when we declare these integer variables, we can say initially they take the value 0. So it is important to assign an initial value to the price. So first, these variables store the max. So these are the store information of the house with the most expensive house. So because we need to print out all the information of the house, so we also store the footage and rooms in addition to price. So here I intentionally show that you can use white space differently. These are whether you use white space around this assignment or not, it's equivalent. So again, we repeat n times. So we first reading information of one house, and then we check whether this house has either 2 or 3 bedrooms. So here we use what's known as the if statement. So this is conditional. So we check. This statement means that we will first check whether what's in here is true. If it is true, then we will execute this part. If it's not true, then we will not execute what's known as the body of the if statement. So I think this comparison. So there's this numerical comparison operator. So this means less than or equal. So one way to express the condition that a house has either 2 or 3 bedrooms is to say the number of bedrooms has to be greater than equal to 2 and less than equal to 3. So these 2 double ampersands represent a logical AND. So this is true only when both this part and this part are true. So this is one way to express this condition. There are other ways. There are many other ways that are equivalent. And inside this if statement, we check whether the price of the current house is greater than the max price. If it is, then we need to update. We need to update the stored information to store the current house. So when this loop is done, we have the information of the most expensive house stored in the 3 variable here. and we print out this information. So in the line using cout, we use a white space character because the problem asks us to have a white space separating the price from the number of rooms and footage. And we use a single quote and the white space in between to represent one single white space character. So if statements, there are two forms. The first form is if, and then a conditional expression, and then statement. So I recommend you always use a parenthesis to be around the conditional expression, just to make it clear. And the second form is if conditional expression, then a statement, and then there's else, also statement. So this means that if the condition is true, you execute this statement. If the condition is false, you execute the statement in the else branch. So one common way of, well, you may see that one way of using if statements is you sort of chain them together. So like this. So if conditional expression 1, you will execute statement 1, then else if conditional expression 2, statement 2, and then else statement 3. So in fact, this can be another else if and so on. So what this means that if conditional expression 1 is true, we will execute statement 1. If conditional expression 1 is false, then we look at conditional expression 2. If that is true, we will execute statement 2. If that is also false, then we'll execute statement 3. So statement 3 is executed only when both of these are false. So syntactically, this uses this second form of if statement. So this red part is one single if statement that is in the else branch. So for conditional expression, for now, we'll just introduce these conditional expressions. So there are 6 numerical comparison operators. So less than, greater than, less than or equal to, greater than or equal to, and also equal, which are represented by 2 equal sign. This is because a single equal is used for assignment. We use double equal to represent equality. So this is inherited from C and also used in Java. And exclamation mark equal means not equal. And there are also logical operators that we use. For example, here in the code here, we use the logical operator and. So this to branch has to be both true for this to be true. And there's also logical or. So A, which are represented by 2 vertical bar. So A or B is true if either A is true or B is true. And then there's also exclamation mark that represent not. So not A is true if and only if A is false. So yeah, we mentioned that we use character literals, this white space. So we can also use, if we need to use other character, if we want to print the A, we can use a single quote and A to represent one character. Okay, so this question, in addition to ask to find the most expensive, they also ask to find the least expensive house with 4 or 5 bedrooms. So finding min is similar to finding max. So it's just that when we check each new thing, we will see whether it's less than the current mean. If it is, we will update the current mean. So this is a part of the code for finding the least expensive house with 4 or 5 bedrooms. So in fact, this code has a bug. So you try to find that bug. So I briefly go through this, and you can pause the video to think about it more if you want to. So yeah, so here we initialize it, and then we read it. So one thing that's different is here we need to find houses that have either 4 or 5 bedroom, and here we use another way to represent the condition. So it's the number of bedroom equals 4 or the number of bedroom equals 5. and we switch the order. So now if the current price is less than the stored price, we will do the assignment. So yeah, I suggest you, if you haven't find the bug, I suggest you pause the video to find it. Okay, so the bug is that we didn't put the right initial value here. So while the code executes, it will always output 0, 0, 0. Because m price initialized to be the value 0, and any price we see will not be less than 0, because all the price for the houses will be positive. So this condition will never be satisfied. So we're never going to change what we stored. So when we try to find the max, using 0 works in this case because all the house price are positive. So 0 is less than all the price we're going to see. So using 0 works. But when we are trying to find the mean, using 0 does not work because we are trying to find a value that's less than this. So we need to set m price to be a large value, to be a value that's larger than any possible price. And in fact, that setting it to be 0 for finding max may not work if the number can be negative. So it works for this problem because price cannot be negative. But in another context, when the number can be negative, then we cannot initialize the max, the initial value for max to be 0. We need to initialize to be sort of the smallest possible value. So the would be a negative number. So here I use in the code that are provided, I use a macro. So define max price to be this number. So this number is guaranteed to be bigger than any price in the house. So this is specified in the constraints. So using this number should be big enough. I think it's more than big enough. And what a macro, this define macro is really just tell the preprocessor to do find and replace. So when the preprocessor see max price, it will replace this string here. So we are really assigning a big number to this price. Okay, to recap the concepts in problem 2, we talk about if statements, comparison operator, SIG comparison operator, and Boolean operator, especially and or. We didn't actually use a not, which we'll use soon, and character literals using single quote, and how to compute max and min.